Hi guys, today I'll be showing you how to graph a function with a horizontal asymptote using the following 10 steps shown here. So I'll begin, we'll factor the top, so minus 2x squared plus 4x plus 6. After we factor it using the rules, we get minus 2x plus 1 and x minus 3. Then, when you factor the top, which was x to the fourth minus 3x cubed minus 3x squared plus 7x plus 6, and then using the factor theorem at the end result from that was x plus 1 squared and x minus 2 and x minus 3. So then we take these two results, and then we put them over on a new function, a new graph. So we'll go minus 2x plus 1 and x minus 3 and over x plus 1 squared, x minus 2 and x minus 3. So with that, we have completed the first step. Next step is stating the domain. So the domain, we begin by xe, come from negative infinity, and then it hits -1. From negative 1, right, we have the union, and then it hits 2. Remember, these are all circle brackets because it never actually touches these points. And union from 2 to 3, and union from 3 to infinity. Now, that was our second step. We can check that off. And now determine any holes. So we have to look for any holes. Any holes are when they have the top and the bottom have the same 1. So we have a hole here because this is the same and this is the same, and a hole here and a hole here. So the holes are at x equals -1. Remember that it's -1 plus 1 equals 0, so that's what makes a hole, and 3. So then we take those points and we plug in. We plug in to the function f of -1 gives us -2 over 0. This function does not actually exist because this is not a real number. So, but we'll still write it down. So we have -2 over 0, and then when we plug in f of 3 to the full equation, we get -1/2. So our other hole is at 3 and -1/2. These are two holes that we've got here. So then we can move on to the next part. Check that off and determining any asymptotes. So we'll start off with x, so vertical asymptotes. So after we completed the holes, we can start cutting things off. So this is crossed off. Sorry, only the square is crossed off because we have 1 on top here and 2 on the bottom. So this becomes a 1, and this one gets crossed off. These two get crossed off. So what we're left over with at the end, after all this is simplified, is -2 x plus 1 x minus 2. This is our new function. We never should be going back to the older one. So now we find the vertical asymptotes. So the vertical asymptotes are whatever makes x not possible. So what x is not possible here? X cannot be -1 or 2. And then we move on to the next part. We have horizontal. Horizontal is either horizontal or oblique. But because here the degree of the bottom is bigger than the degree of the top, right? We have a degree here of actually x of 0, and here we have a degree of 1 and a degree of 1. So this is 2. This is big, and the smaller one is bigger. So that means we have a horizontal asymptote. So the horizontal asymptote, which is only exclusive with a oblique asymptote. You can't have one and the other. So this one is just y equals 0. Whenever we have one bigger than the other, whenever it's a horizontal asymptote like that, then we have y equals 0. So that finishes off our next point. We can check that off. Now determine the x and y intercepts. So to find an x and y intercept, we need to find an x-intercept. So let's start again with x-intercepts. An x-intercept, I'll just switch the color. X-intercept is whatever makes the top equal to 0. So -2 is the top, right, from here. This is -2. And we can see here that nothing makes -2 equal 0, right? There's no variable over here. Like, there's no x over there. So what we would have to do, so that means there is no x-intercept. We have none. Now y-intercept is whenever x equals 0. So x equals 0. When x equals 0, when we plug in x equals 0 to this, we get 1. So we then have y-intercept at y equals 1. Let's go back to our chart. We can check that off. So a reciprocal quadratic. So whenever we have a reciprocal quadratic, we have, just give me a moment, I'm sorry. So whenever we have a reciprocal quadratic, let me just write it down on the cross. So a reciprocal quadratic is a constant at the top and a quadratic at the bottom, like we have so here, right? We have -2 at the top, which is the reciprocal. Sorry, let me make that arrow nicer. We have -2 here, and here we have x plus 1 and x minus 2. So when we have a global max or min in this, right? If we were to flip them over and we would say this would be on top and this would be at the bottom, you see how they're flipped? So whatever point here would be the global max or min would become the local max, so in the specific area. So here we find the middle point, so we have 2 plus -1 divided by 2, because we use the 2 points. So 2 is coming from the -2 here. That's 1 point, right? Remember that when we have in this form, it means that it's the x-intercepts. So here it touches in, here it touches in -1. So, sorry, it's a +2. So here we have 2, and then we add the other one. So plus -1, which gives us 1 over 2, which gives us half, right? So there is so at the x-intercept of half, that is the global max. So then we plug in a half back into the original equation, this equation. So we take -2, 0.5, right? Plus 1, 0.5 minus 2. And from there, we have, that means our new point that we get, because we plugged in, means that we have a half and 8/9. That is our new local min or max or min from the reciprocal. Then we move on. We go back to the original one. We go see what happens here. reciprocal, we can check that off. And now determine the positive and negative intervals. So by this, we're going to make a chart. So we actually make a line, and we separate the line by the x-intercepts and the vertical asymptotes. So what are the x-intercepts? We have no x-intercepts, right? We've seen here we have no x-intercepts. And our vertical asymptotes that we mentioned before are over here. These are our two vertical asymptotes, the VA. So we have -1 and 2. So we split up our graph into -1 and 2. Sorry, fix that. And 2. This is infinity, negative infinity. And then we start building our test cases. Test cases. Right, so the test case in between these points, we're going to have 3 test cases. So this one can be -2, this one can be 0, and this one can be 3. And then we use every single part of our function. So -2, so right here -2, x plus 1, and x minus 2. And we have our final, we're going to have a final positive, negative intervals. Just bring down the line. So -2 here will always be negative everywhere because there's no x as if to put in, right? There's no variable, so it will always just be negative. Now here we'll go across, so we'll have negative, negative, and negative, so our final is negative. On this side we're gonna have a positive, then a negative, so it's a positive, and this side is a positive, positive, so we have a negative. Those are our intervals where we get where we get negatives or positives. So now we will check that off. Now, so the graph number 8 here, we do not actually have to check if it crosses the asymptotes. And this case happens when the horizontal asymptote is y equals 0 and there are no x-intercepts. That means the graph will never ever cross that line because it has no need to touch the x-axis because it has no x-intercepts. So we can check that off. And now we got to draw up the graph. Okay, so we begin by drawing our horizontal. Let's begin by drawing our horizontal asymptote. So I'll draw them in blue, the asymptotes. So we'll cross a line here. Let me just make that bigger. This is at 0. Right? And now we will use our vertical asymptotes. Is x minus 1 and x equals 2. I'll make that yellow. Make that red. So we'll go up. We'll snake up. -1 and 2. So those are our two. Sorry for the hard drawings. Now, from there, we will now look. We will look for actually the hole. Where do we have our hole? Because this hole here actually doesn't exist, because you can't have something over divided by 0. This is the only hole. So 3.5. So we'll make a hole at 3.5. So we have 1, 2, 3, and then we'll do a half. So we'll actually make a tiny little hole there. That is our hole. That symbolizes a hole. And then from there, we'll start graphing. So from our test cases, from -infinity to -1, it will be negative. So how do you draw that? You always want to make sure that your graph closes into the asymptote but never touches it. So it's always going to be something like this, right? Because it's always negative, and you always want it to be touching this asymptote and this asymptote. Next, you will move on to the next one. From -infinity to, from -1 to 2, it's positive. So we'll go from there. it's positive. And this is where we get our quadratic. Because it has to be inside of this line, inside of this barrier, and needs to be approaching this asymptote and this asymptote, it will become out like a quadratic. It will look like this, right? This is, and these two lines next to it are the asymptotes. And that's where we use what we got for our global max and min. Our new max, our new local. This point here. Half and 8/9. So we take that, we look for that point. So at half and 8/9 is right over here. And we also know that, sorry, let me just fill in this hole. We don't want it to look like this, right? This is simplifies as a hole. And then we have actually as well a y-intercept. We should also put that in. You always want to put in the points first and then draw. So we have a y-intercept here at 0, 1. So we'll zoom in, and the y-intercept is right over here. That means from here, we'll go like this. You will approach the asymptote like this, and approach the asymptote like this. Sorry, it will never actually touch, just in my drawings. It does. Let me just try to fix that. Right, it will go like this, and the other one will go like this, with this point here as the local maximum, because this is a local, right? This is a local function. This is the whole function over here. And then we look at the last one. Our last position, from 2 to infinity, it is negative. So like over here, we will draw, but then we have to reach the hole, right? So we see the hole. We can draw like this. Sorry, it's got to be a little bit more, round like. So we're going to draw like this and like this. You see the hole. The hole should not be filled in. If it's not filled in, it symbolizes the hole. And this is the entire function. This is how it looks like. So we can check that off. Now we got to state the range as our final thing. So we'll write the range next to it. We'll write y e. So it begins from negative infinity, right? It begins from here, the infinite line down there. It goes all the way up, right? Notice that we have a hole here, right? But because this function continues to go through all the way up to 0, this hole doesn't really matter because y covers the entire line here, right? All the way up to 0. So we write 0, but because it never touches 0, right? The asymptote stops it from touching 0. Right? So it's actually circle brackets. And then we add a union from this point here, right? The new local maximum of the quadratic is 8/9. Right? And then all the way to the top, like we had below, is infinity. And because it doesn't touch infinity ever. But I made a single mistake. This should be square brackets because it actually touches the local max or min point here, but the infinity should not be. So this is how you draw a function with a horizontal asymptote using these steps. I hope it was helpful, and I wish you a good luck. And thank you. Please subscribe and like and share the content. Thank you.